we're asked to simplify this. When we first look at this, we see all these negative exponents, but what this really is a complex fraction because these turn into fractions, right? Because I don't have something that I can apply those exponent rules to because we're not multiplying or dividing, I'm going to start simply by rewriting all of this with positive exponents and hoping I can do something with it. So this is going to become 1x plus 1y over 3 over x squared plus 5 over y squared. Notice this right here and this. This went to 5 over y squared. It did not go to this. Why didn't it? Because that -2 only applies to the y, unless there was parentheses. So this would be this. This is this one because that 5 is separate. There's no connector to that exponent. So really careful. This is probably the single biggest mistake in rewriting these. And it's something we went over back when we did exponents, but it bears repeating now as we're using it within another problem. Now, when I look at this, I have this addition in the middle. It's not just a fraction over a fraction. I have two separate. So this is going to be easiest to use method 2. And so I'm going to multiply by something that's going to clear all the denominators. So I'm going to use x squared, y squared. I can do this because this is, of course, just 1, so I'm not changing anything. And I'm always looking for the highest exponent of each. Okay, so you need the highest exponent, so it includes everything. The same discussion we had when we were simplifying things, when we were getting least common denominators, all that. So I'm going to take this term, and I have x squared, y squared over x plus x squared, y squared over y. Because remember, this is really over 1, so this is going to the numerators. Okay? Then this bottom is 3x squared, y squared over x squared plus 5 over x squared, y squared over y squared. Now I'm going to go through and I'm going to do some cancellations here. So what comes here? Well, this, I can apply my quotient rule. So then I get x, y squared. Then here, quotient rule again, but x, y. Then down here, this and this completely canceled. So y squared plus 5y squared. Okay, now I ask myself, can I do anything? So let's see here. Can I do any factoring of this? On the top, I can take out an x, y, and I'm left with y plus x, right? So I took out an x and a y, leaving me one y here, one x, leaving me an x, the y. And then down here, can't do anything. So nothing's going to cancel. This is going to be my final answer. This would actually probably be fine, although looking at these x's and y's, a lot of times I will factor, hoping something will cancel, and often it will. In this case, it didn't. So sad. But, you know, you can always hope. So hopefully this helps you walk through this. The big thing is to use those exponent rules and rewrite them so then they look like the rest of the problems from this section. And then you can just simply then decide method 1 or method 2 and proceed that way.